So you have a guess that the mean life of the battery is less than 500 days. This is opposed to what the manufacturer claims. So there really are two hypotheses, which are just guesses here. The one that the manufacturer claims and the one that you believe. So again, it's helpful to have names for these things. And so again, we get a few new definitions here. So a null hypothesis is a statement of no change, or no effect as we're looking at experiments and things, or no difference from what they've claimed. This is a statement that is assumed true unless there is significant evidence to conclude the alternative hypothesis. So the symbol used for the null hypothesis is H sub 0. So the alternative hypothesis, this is a statement of a change from what was currently believed, or an effect that some drug or something might have had, like in a medical study, or a difference from some claimed value of the parameter. So this is what you're hoping to prove when you reject the null hypothesis. So there are two symbols that are commonly used for the alternative hypothesis. So H, cap H for hypothesis, and sub A for alternative, or H sub 1. Okay, so some books use 0 and 1 for that pair of hypothesis. This particular book uses 0 for null, no change, and A for alternative. So the symbol HA will be used in this book. So when testing a mean, the hypotheses, when we put them together, look something like this. So we've first got this statement of no change, mu equals some specified value, mu sub 0. And then we have to pick one of these three alternatives that we believe to be true. So either we think the mean is less than what was claimed, as in this case, or we think the mean is higher than what was claimed, or we just think that the mean is just plain different from what they have claimed. So we're going to pick one of these depending on what you're trying to prove. And so again, as we look at the graphs for these names are going to make some more sense. But a left-tailed test is going to be a hypothesis test where the alternative hypothesis says that the parameter is less than the specified value. And that's because the probability piece that we'll be computing will be the area in the left tail. For a right-tailed test, a hypothesis test where the alternative hypothesis says the parameter is more than the specified value. And again, we'll see with the pictures of the distributions that in this case we're going to be shading and finding the probability and area in the right tail of the distribution. And a two-tailed test, we don't do these very often. Usually we are more specific about which direction we think the change has happened, whether a parameter has gone up or down. But a two-tailed test is a hypothesis test where the alternative hypothesis says the parameter is not equal to the specified value. So for this particular problem, the pair of hypotheses would be as follows. So the null hypothesis, the statement of no change, is that they claim it's 500, so we believe that the mean is 500 days. The alternative hypothesis that we're hoping to show and that we believe to be true, we think that the mean is actually less than what they've claimed. So we have some evidence that the population mean is less than 500 days because our sample mean was only 490. So the sample mean is less than 500. But simply having a sample mean less than 500 does not prove that the population mean is less than 500. Okay, so this is where our probability distributions are going to come into play.